Hi everyone, my name is Noman. I'm one of the AIs for this course. So today's video is gonna be on the walkthrough of Lab 2 solutions. So I'm not gonna kind of try to delve into the details to how to solve these questions. So to start with, let's go to the assignments, and then if you click this, you'll see that so GitHub is gonna render the IPython notebook file even if you don't have the Jupyter notebook. So basically all you need to do is click raw and then save it from here, clicking save as, and the format should be all files, and then save it. So I've already saved it, so I'm not gonna do it again. And I have opened the Jupyter notebook server, and if you see that I have already the file that I have saved, so I will open it. Okay, so for this lab you'll have to know the data types of Python, and if you're not familiar with it yet, then you can go ahead and then click these links. If you see, you can go to the Python documentation, the informal introduction to Python, so it will be on the numbers and strings and all those different data types, and then the control statements like if and for, and the different data structures that you will need to code, and then what you're going to be using for the remaining of the courses, such as like lists, sets, dictionaries, tuples and stuff like that, and then functions and modules, and probably a little bit of object-oriented programming as well. So I'm not going to explain these things, so these are pretty straightforward if you already know Python. If not, then try to go through these things and know the basics before you jump into the assignment. So as you can see, like Jupyter Notebook and Python and Panda, they work together for the data science things, because it can create interactive visualization within one notebook. Instead of creating the Python file, what you can do is do the Python codes, and then you can see that there's like markdowns and then headings and codes, all those different sections that you can do. So this is pretty cool. So if you're not familiar with pandas as of yet, there's a 10 minutes tutorial to pandas. If you click this link, it will take you straight to the pandas documentation, and there is a 10-minute introduction to pandas. There's a video as well in YouTube. If you search for it, you'll see. So basically this is just the introduction, and then going through how the pandas data frame work, how you can store data and how you can index and then retrieve different values based on. So basically this you can do all those different things that you can do in a regular database like SQL or Oracle. So if you're not familiar with it as of yet, then you can go through these links, and then if you'll see, like if it's too brief, then you can see like there's detailed explanation of all those different sections over here. So that'll probably take a little bit more time, but that's worth it if you wanna learn Panda. So I'm gonna close this tab. So to import Panda, you can see you have to use the import pandas as PD. That's just a alias that you create, and then what you do is basically you can check the version, and then there are like a bunch of different data files that pandas supports. So for example, you can have your data in forms of text file, you can have it as in forms of CSV, it can be in Excel, it can be in JSON. So pandas basically support all those different data sources, so you can essentially load from all of them. So right now what we're doing is we're loading the data set about the Jon Snow's map and the location of the pumps. It's basically an XY coordinate. So since this is already loaded in the GitHub, so you can just give the so we'll run through all of this so that we can code later. So as you can see, if you execute this command, so basically you can do a control enter So it will execute the command. So this doesn't have any output, so it's not showing anything right now, but it has loaded the pumps.csv file, which has got the coordinates of the pumps, and it has loaded that into that pump_df data frame of pandas. And if you see, like, you can check the head, so it will essentially bring up the top 5 rows of this data frame. And now you have to print the first 3 lines. So this is pretty straightforward. What you do is, since you have the dataset ready, so you can do pump_df.head, which will bring the top 5, but you need the first 3, so you will give a 3 here, and then if you put a control enter, then you can see so these are the first 3 rows or the data for the pumps.csv file. And you can always sample. So basically what this thing is doing, it's taking the top 3 rows, or the top n rows, the number of n you give here, but then if you wanna get a sample, I mean like a random distribution, instead of getting just top 3, then you can give a sample, the data frame.sample function. And then if you want to use the length, so it's going to return the number of rows, and basically the size is it's not the number of rows, it's basically the number of elements. So basically this is a 2 by 3 matrix, so it has 26 elements, and that's why it's returning 26 over here. And then that you can verify using this df.shape, which says it has 13 rows and 2 columns. And then you can always use this dataframe.columns command, which will return the name of the columns, which is x and y for our data set. And then basically if you use this describe function, it will return all those statistical descriptions for the dataset that you're using. So if you see, there's like 13 counts for both x and y, and what is the mean of this value, the standard deviation, and then like the minimum and maximum, and this 25%, 50%, and 75% percentiles. So basically this gives you an initial impression of the data that you're using. And then there's like bunch of different techniques that you can use. For example, like you can slice the data frame. I mean, if you wanna see like all the columns and just the 2 rows, you can slice the data frame like this. And then if you wanna see just the last two rows and all columns, it's basically like the slicing that you use for the list in Python. So it returns the last 2 rows, and then this returns from 1 to 5. And then you can always like you can always filter these rows based on some conditions. So for here, it's like basically filtering all those rows that has got the values for x, which are 13 or higher. In fact, it's strictly higher. Okay, so now we are gonna load another data set that's called the death data frame. So it's essentially the same as we have done earlier. Instead of writing it down again, probably you can copy and paste. So here, copy, and then come here and then paste. So instead of using pumpdf, probably we can use deathdf, and then we need to change the name as well. It's gonna be deaths.csv. So let's see if it works. Okay, it does. So, and then it asks you to show the first 2 rows. So it's gonna be death_df.head2. So that's that. So this is the first 2 rows, and then okay, so then it asks you to show the total number of rows, which we have already seen. You can use the len function and then give it, then it's going to return the number of rows, which is 578. So okay, that's that. Okay, now we are trying to get into the visualization part. Basically, Panda does support visualization, so you don't have to import the matplotlib explicitly. It basically gives a visualization interface, and it basically uses the matplotlib under the hood. So if you just give the depth_df.plot, it's basically going to return something like this, which is probably in the first glimpse is not meaningful. And for some cases, if you don't see the output in the Jupyter notebook for some reason, then you can just give this function, which is basically a magic method. And if you give this this percentage matplotlib inline, this is gonna say that this graph has to be shown right here right now. So just in case if you're not seeing any graph in your Jupyter notebook, then you can like use this. Sometimes if you see, like if you just give the plot command, then it's gonna return something like this. So and it's not gonna show anything, like there is no plot. So if that is the case, then you can use this before, and after this, if you execute this command, it's gonna show the plot. So as you can see, if you intend to get a scatter plot, then you can give that dot plot, and then you can give the coordinates, which is x is the x column of our dataset and y is the y column of our dataset, and the kind of the plot that we are drawing is the scatter plot, and then the labels that we're using is the depths. And after this thing is executed, then this plot is going to return the default size of the scatter plots and then the default color. And if you're gonna change it, then you can always give the size. You can play around with the size, and then you can change the color anytime. So right now we have smaller, after giving explicitly mentioning the size of the dots and then the color, you can see there's a change. This essentially is the same graph, but with different visualization. And then you can always plot the pump dataset and the dead dataset, both of them. But what about if you wanna put them together? So right now, whenever you're creating, whenever you're invoking the plot method, it's creating a new plot. But if you wanna see both of them together, then you have to create an axis object and then pass that axis, so that both of these plots are plotted on the same axis. So here, what is an axis? If you can see the x and y axis, and then a figure can have multiple axes like this. Both of them have multiple axes, and then an axis can have multiple plots. So this is basically a uniform axis, and then you can see there's two plots. So if you want to group both of these plots together, like here, then what you're going to do is when you create the first plot, then it creates an axis and returns, so you can hold it into a variable called ax or whatever. And then what you can do is, whenever you're drawing the second plot, this was for the depth df, and whenever you're creating the second plot for the pump data frame, then you can essentially, after mentioning all those parameters what you did earlier, you can explicitly mention the name of the axis. So basically what you are doing is passing the axis that was returned before, and then saying that group both of these plots together using the same axis. And after this command is executed, you can see this plot contains both depths and pumps coordinates with the same axis labels. Okay, now we are turning into the next section, which is the Warner diagram. So basically, Warner diagram is a computational geometry based diagram which basically creates or separates a map into disjoint sets. It creates convex polygons when based on some points. So if you invoke the scientific Python module, and you can use the spatial.voronoi and spatial.voronoi underscore plot 2D packages. So if you wanna, so first we import them here, and then if you click these links, it's gonna take you to the scientific Python documentation for Voronoi and Voronoi plot 2D. You can see it creates a Voronoi diagram of n dimensions, and you have to pass the points as NumPy array or matrix. So as you can see here, whenever you are creating an object of this Voronoi class, then you are passing the points as a NumPy array. So basically these are the coordinates that we're going to use. And then this is basically just for like the Voronoi plot 2D is for plotting the Voronoi diagram or the Voronoi object that you have created here. So it asks you to produce a Voronoi diagram that shows the death pumps and Voronoi cells. So before going into your code, you need to like somehow transform these points into a 2D matrix. You can use this as matrix, or you can use the NumPy array. So basically what we're going to do here is create a Voronoi object. So give it a name Voronoi, and then we are creating an object of this Voronoi class. Okay, and then what we're going to do is we're going to plot the axes. So we have already done that, so basically copy and paste from here. Sorry about that. So yeah, so now we have got both the plots, but right now we have the Voronoi object, but it's not been plotted yet. So what I need to do is essentially invoke the Voronoi underscore plot underscore 2D, and then we need to, so if you go to this documentation, you can see it requires the Voronoi object, and you can also pass the axis that was previously defined probably. So we have created the object which is called Voronoi, and then we will also have the axis. So axis is gonna be x, and let's try. Okay, we're having, oh, so I think we need to run this again, and then this. Okay, so now it works. So you can see this thing has been as you can see that both the deaths and pumps points are here, and you can see the convex polygons that I was talking about. So basically these polygons are based on these data points, and then you can always query any other data point from here and then see which is the closest object. So basically you can save this figure as well, like the figure that you have created, using this like importing matplotlib and then plt.savefig. It will be saved in the directory where you are running this Jupyter file from. So right now you have to save this Voronoi diagram that you have just created, and this is pretty straightforward. So we have to, I think we have already imported matplotlib, so we don't have to do this again. Okay, so what we need to do is basically we need to copy and paste this whole thing again, and then we need to execute that plot.savefig. command and then give this some kind of name. So for example, test underscore Voronoi, or probably vd dot png. Okay, so now we have this. So now we can execute this, and if you go and check in the downloads, it has this test vd.png file and it has this Voronoi diagram. So we have successfully saved it. So now comes the final part, which is the HTML and CSS basics. Most of you should be familiar with this stuff. I mean, whenever you create an HTML file, if you double click it, it automatically opens up in your local browser. But sometimes if your HTML file if it has JavaScript or datasets, then sometimes it creates trouble. So what we are going to do is run a local web server using Python. So what we are going to do is execute this command from our terminal. Let's create a new shell, and then probably we're gonna change the directory. I mean, the directory that you're gonna go into, it's gonna be your root directory. So from here we're gonna run this command. Okay, so it says address already in use because I have already opened it once. So let's see, localhost. Yeah, so you see, like we have already created so basically we're using this computer as a server, and then the port number is 8000 and the IP address is 0.0.0.0. So basically what you can do is, so this is your root directory where you're creating your server from, and then this has got all these files. So if you have the HTML file, then you can like execute it from here, like open the HTML file using this server. So they're like HTML, like these are the basic HTML reviews. If you see, like HTML is basically a markup language, so there's a bunch of tags. For example, HTML tag should precede in every HTML file, and then head, and then title if you want to give any title to your web page, and then there's a body, and then there's different h1, h2, h3 headings. The paragraph stuff goes into P, and then divisions and spans and all those things. You should be familiar with these things. And then about CSS, if you can see there's a CSS selector. CSS basically is a style sheet that is used to customize your website or the web page that you write in HTML. So selectors are the HTML elements that render specific styles. So for example, here all the body elements of your HTML file is gonna be steel blue because you have changed the color to steel blue using your style sheet. So there's like 3 different ways that you can incorporate your style sheets. You can give it a style tag in the head of your HTML file, or you can create a separate CSS file and you can import it in your HTML file, which probably is most robust way of doing, because like otherwise if you do this, the code becomes lengthy and messy sometimes. And then the other way of doing is doing inline. So whenever it's required, like for example here, if it is in a p tag of an HTML file, you need to customize the color to green, then you can do something like this, but this is gonna create the whole code messy. I mean, sometimes it's useful, but then like if it's something that requires a particular, probably a 1 or 2 text to be customized, then you can use this, but otherwise it's advised to use the exclusive style sheet file and then importing it into your HTML. So for the next part, we need to create an HTML page that displays the Warner diagram that you have created. You can incorporate any kind of styles, and then you can run the Python web server that we have already done, and then open the HTML file that you have created. So basically what you need to do is, I have already done, I guess, let's see. Okay, so this is the test_html file that I created with the figure that we generated from our Warner diagram. Then we're gonna save it, and then we have renamed it. So after we go to the localhost and then give the HTML file name, or probably you can start from it here. If you go here, then here, and if you give this, then it shows the Warner diagram. But this is basically a basic rendering of the image that is saved into an HTML file. You can do other styling using the CSS style sheets. Okay, so I guess that's pretty much it for this assignment. I'll be posting a new video on next week on lab 3, and make sure if you have any questions, post the questions on Slack or email us, or probably join us using the Zoom meeting links in the office hours. Thank you.